All right. Good morning, everybody. We're almost the end of the morning, almost the end of this conference. Well done making it all the way to day 3, and thank you so much for joining me for this session. My name's Phil Nash. I am a developer advocate at a company called Sonar. Sonar is responsible for tools like SonarQube and SonarCloud and SonarLint, static analysis tools that will help you write better, cleaner code. SonarCloud and SonarQube live in your deploy pipelines to tell you if you're doing things wrong, and SonarLint will live in your IDE to help you write better code. So ever interested in that, check those out, and also ask me about them anytime. Again, as I say, my name's Phil Nash. You can find me all over the internet as Phil Nash. Any social media network you can think of, I'll probably be there, even all the new ones. We've run out of ideas at this point. There's seats down the front if you are coming in at the back. I don't bite, I promise. So we're here to talk about the state of passwordless auth on the web. And I just need to start by saying that passwords, and I hope you agree with me on this, I really hope you agree, passwords are terrible, right? They're a bad thing, they're bad, and I'm going to prove it to you. Don't worry, there's going to be holes that are proof on this. I'm going to prove first with data. Back in 2018, end of 2018, Google did a poll, a survey of a bunch of people, and asked them various questions about passwords and their use of them. And one of the questions was like, how often do you reuse passwords? And the answers, the available answers were all of the time, sometimes, and never. How often do you reuse passwords? And so like this blue section here is the some of the time. 52% of people said some of the time I reuse a password. And I feel like that's good, that's honest, that's fine. I've done that in the past. That's reasonable. Then there's the 35% of people there in the green and never reuse passwords. I like those people understand passwords. I'm assuming we're actually all in that bracket now. You're all out there using a password manager. You don't even know your passwords, do you? But what I'm scared of is this little yellow slice down here, the 13% of people that said that they reuse passwords all of the time. Like, these are the people that are dedicated to a single one password. I mean a single set of characters, not the application. They are dedicated to one password for every single one of their accounts. And they've probably decided this is a good idea in their mind, and they are unaware of all the dangers that could bring. Now, I want you to remember that, so 35% of people said that they never reuse a password. But this same poll, this same survey, asked whether people use a password manager as well. And the number of people that answered, yes, I do use a password manager, is 24%, which is a bit of a gap, I think. I'm a little concerned about that, because that's 11 percentage points of people there who I guess have a really good memory, or a lot of sticky notes around their monitor, or some kind of other system or scheme that allows them to have a different password for every account, but not put them in a password manager. I know I have about 400 accounts in my password manager, and I feel like that's probably not that big. So a little concerned. I guess the final thing is they could just be lying. You're allowed to lie at surveys. It's fine. But it's terrifying. It's terrifying. The flip side of this, of course, is that means more than three-quarters of people are not using a password manager, and that's why we have to worry. That's what we're worried about. NordPass, which is one password manager, did a survey back in 2022 to find out the top 10 passwords of last year. I always like the battle between password and 1, 2, 3, 4, 5, 6 for who gets the top slot each year. Apparently in 2022 it was password. Normally it's 1, 2, 3, 4, 5, 6. It's easier to do that because they're all in one row, right? Typing out the word password is actually harder than one would expect. I'm looking at my keyboard. And then I also like that 1, 2, 3, 4, 5, 6, 7, 8, 9, for the password for less lazy people, because you have to get all the way to the end of the characters, is in there at number 3. Wonderful, wonderful stuff. Using an easy password like this obviously makes it very easy to break into your account. And when we consider all of this kind of stuff, we're absolutely considering the fact that an attacker doesn't care who they break into necessarily. They care that they can break into some accounts. If they can take over some accounts, then they are winning. Unless targeted attacks are a different thing, but So even if you're not using one of these lovely passwords here, if you're using something that you have thought up, but maybe you are repeating, it's very much the case that sites and applications out there are leaking passwords all over the place too. Almost every big name site has leaked passwords, and every tiny website you've ever been a part of has leaked passwords. The wonderful Troy Hunt has been collecting those passwords for years under the haveibeenpwned.com website, where you can go check if your passwords are live, available on the internet. I know I'm in there several times with passwords I used to use multiple times, and that was bad. I got hacked into accounts myself. I recovered everything, it was nice, but I did spend apparently quite a while on Skype asking men in French if they'd marry me, which was, was an experience. So passwords are terrible. I hope we agree, right? Like, they are hard to make people do correctly. Even if you do them correctly, sites will leak them to other places. And as developers, as people who actually are responsible for the applications and for the people that use our applications, it's fine that some of those people are able to deal with passwords correctly. It's the ones that don't know how to that we're actually responsible for and we need to keep safe. And so that's what the rest of this kind of talk is about. How do we better keep our users safe, even if they are insistent on using the password. On the other hand, passwords and account security and logging into an account is sort of a bit of a trade-off, right? Nobody ever comes to a site simply to log into that site. They come to do the thing that comes after logging in, after registering for the site. And so we end up with this set of trade-offs between both user experience and security. We have to provide our application in a way that people want to use it and are happy doing so, but without them getting hacked and losing all their data. And I don't think security necessarily always considers the user experience side of things. So that's kind of where I want to go for the rest of this talk as well. We're going to compare the user experience versus the security of a number of methods and see how we can improve things and how we can eventually get to the point where we can remove passwords and make things incredible all round. So we'll start by taking these two axes and talking about passwords on it. And so on the user experience side of things, passwords are, it's hard to remember good passwords. It's hard to choose good passwords. You need a third-party piece of software in order to actually do this correctly. And that's a bad experience all around. That's a shame, right? It's the one we build into almost every application, but it turns out it's really just hard to actually deal with this. On the other hand, they're not very secure. If you pick a bad password, it's really easy to break it. If you pick a good password, some other application's already told the rest of the internet about it. And I haven't even mentioned phishing yet, but of course things are vulnerable. Passwords are vulnerable to phishing as well. And so passwords, horrifically bad security and experience. But it's the default right now. So what can we do to change this? Can we make it better? Well, first up, obviously the answer is to use a password manager. I'm a big fan of Bitwarden, open source password manager, thank you very much. And that's where my 400 accounts are all stored. Wonderful. But again, I'm not talking necessarily to people who are using password managers. In fact, it's a good experience, right? When you have a password manager, and I'm going to imagine most people in this room do, when you have a password manager, you know that this is easy, right? You now don't have to worry about ever thinking up a new password again. There's no repetition. You just generate it, forget it. It doesn't matter. You even get sort of an autocomplete inside the browser, which is wonderful. So you end up with these long, difficult-to-remember passwords that are unique, and it's still vulnerable to phishing, although slightly less so, because if you're using that autocomplete functionality of your password manager, then it checks against the domain that you're on, and if you're on some other domain trying to log in as another account, then you're actually kind of kept safe by that. It makes you think about it. So that's good. But if we go back to that survey we had before, only 24% of people were admitting to use a password manager. And so it's not the answer. Like, if we have our application, we can't for the most part, we don't we're unable to mandate use of some third-party application just to log into it. It's up to the users to decide that. But can we improve this? Is there anything on the web platform that gives us the ability to make this better? Yes, thankfully. That's what it talks about. I'm going to start with some very simple things. Just in the HTML, if you slap the autocomplete attribute onto an input element, it opens up a world of possibilities. Autocomplete new password will offer to generate the user a secure password, a randomly generated one. This is what it looks like in Firefox. It doesn't make the user take this option, but it gives them an example at least to say, hey, you do need a strong password here. I like that. And it's a simple attribute. It takes nothing to add. And then when you get to like a sign-in page, for example, you can add autocomplete username to help get the user's username onto the page. Autocomplete current password, so we can help browser password managers to fill in things automatically as well. And then, of course, we have this current password and this new password thing, which even makes it work when you're doing that password update page and you have to put your old password in and your new password twice. Without these attributes, then your password manager is going to fill in all three the same. This makes it better. So that's a good start. I love that. And it's just attributes. I like including type of email as well on the input, just to encourage that encourage the browser or password manager, whatever, to understand what the content of the input is. These are great little tools to help both users and the actual software we're using to interact with this understand what actually goes in the form. Then we have what's known as the Credential Management API. It is not the most exciting sounding API in the world, I can tell you that. But the Credential Management API underpins effectively the rest of this talk. It's actually been around for a number of years, and I just don't think it gets the press it deserves, or certainly not under this name anyway. The Credential Management API, at least in its initial form, allows you to store and retrieve credentials in the browser, using basically the browser's password manager, which for most people, for most users, is good enough. And I like that. So when you can store and retrieve credentials in the password manager, we get to give users a better experience as well. You see, the code looks a bit like this. We ask for whether we have the password credential object in the browser in JavaScript, and then this code you'd run when you know you have had a successful login. So either at registration or at login time, we know that the password is correct, and so we put that into a password credential object, and then ask here the browser to store that password. We say await navigator.credentials.store and that password credential object. When we do that, this pops up the browser's permissions dialog to say, hey, would you like to store your username and password for this website? That's actually something that people see normally anyway. The browser is quite good at offering that kind of thing. But when we're in control of it, it turns out that we get to do much cooler stuff. Because if you have asked to store that password, then later you can ask to retrieve it again. You can ask Navigator credentials get me a password, and that pops the permissions dialog up again to say, hey user, do you want to use the password that's stored for this website? If they say yes, you get the credentials back, you can autofill a form in, and you carry on. And it's a great experience. You can even do it silently. Now, I'm not entirely sure of the security repercussions of kind of silent logins like this, but you can do this silently and just have a user pass straight through your login page if they've stored your credentials already. So asking for an unmediated version of this doesn't do the permissions dialog. Notably, of course, if a user has logged out, you probably don't want to sign them back in immediately, silently. And so if somebody logs out, you do want to call on prevent silent access to make sure that doesn't happen. So that's just one thing to remember if you go down this route. And this is what it looks like, though. I'm going to screenshots for this. This is me on an Android device. I've done a login, and now it's saying, hey, do you want to save your password? It's actually going to save to the Google account in Android, which is great because it then syncs across to the desktop as well. And when you hit save like that, it stores it in the browser's credential management. It stores it in the browser's password manager. Then when you come back to log in, and you trigger that navigator credentials get, asking for a password, it pops up this little thing. Now, obviously, there's some awkward things here. I'm using a weird domain name and stuff, but it says, hey, do you want to sign into this website using your username? Obviously, this is not a thing for people to be using on public devices in the library or whatever, but if it's on their own device, then we can pop this up and say, hey, do you want to sign in as you? And they can hit sign in, and they're straight through to the application, straight through to what they wanted to do. It's wonderful. It turns signing in with a password from a multi-step typing in your password that you were supposed to make random and, I don't know, probably didn't, into this one-click experience. And so if we look at this on the axes of user experience versus security, the experience suddenly gets a lot better. We get these one-click logins. Once somebody has chosen a password in the first place, and we can have the browser generate that to be a secure password if they agree to it, we get one-click logins and no need to remember passwords. Even like with a Google account, for example, syncing across desktop and mobile. Very nice. However, we can't make the user pick a secure password, even if we offer it up as best we can. And so it doesn't really fix any of the existing kind of security issues on this. And again, finally, it's also sort of less vulnerable to phishing just because if you expect to be asked that kind of, do you want to just sign in, and instead a site asks you for the username and password that you don't normally use, then you're less likely to put it in. So it's kind of helpful for that. So yeah, credential management API is one of my favorite things. Store password credentials for people and give them a better experience logging in. Wonderful. Still using passwords, of course. We can get rid of those later. So passwords, the security remains bad, so let's use two-factor authentication, right? I'm sure we've all set this up on a bunch of accounts. You either get yourself a text message or you've got yourself a mobile app which is generating codes and helping you log in. Wonderful. I'm going to go straight to the sort of looking at this in a way, because the experience, we've taken a step back here. Like we have regressed our experience. We went from this one form we had to fill in order to get to the thing we needed to do to a two-stage process. You probably need another device, or if you're on your mobile device, you have to open another app in order to deal with to get your code. If you're doing it via SMS, then you require phone signal. It's an absolute nightmare of an experience. I'm absolutely guilty of trying to log into a thing and then reaching for my phone and then scrolling on social media for 20 minutes and then realizing I was supposed to be logging into a device and then it tells me that the code is timed out anyway, and it's a bad experience. Security, though, is good. On the security side of things, we can leak our passwords all over the place, and if the person doesn't have access, if an attacker doesn't have access to our device or to our phone number, then they still cannot get into our account. Thank you. It's vulnerable to phishing. If you can build a website that takes in somebody's username and password and plays that again onto the original site, you can build a website that takes in a username, password, and a code to get through as well. And then finally, you're right, sorry, it's phishing, yes. But finally, if you're doing this via SMS, which is probably the most accessible way to most users, it is possible to kind of make a targeted attack on that. This is not something that you could do to just generic every user, but if you know somebody's phone number and the account is high enough value for you, you can absolutely target that. And the SMS system is incredible because there is no security in it. It's amazing. Ask me how I know. Later. This is not a talk about how bad SMS is, but my goodness, yeah, if you know who you're attacking, you can absolutely just take their stuff. Which actually is a funny thing. You know, earlier in the year, was it this year? Yeah, when Elon Musk decided that Twitter could no longer do text message two-factor authentication unless you paid for it. Like he took SMS two-factor authentication away from like regular Twitter users. And some people in security celebrated this. They were like, yes, SMS is a weak form of two-factor authentication. But it's only really possible to break into SMS if you are targeting a person particularly. So it has to be high enough value for that. And it turns out that most people who are not paying for Twitter were also probably not a high enough value account to make it worthwhile attacking like this. On the other hand, he did allow SMS as a two-factor authentication thing to be open still for people who paid for it, arguably more likely to have a high-value account that's worth breaking into. And so what Elon Musk did there was remove a whole bunch of security from people who needed it and still make available the more difficult one, the one to break for people where it's worth breaking into it. So that was a bad idea, simply enough. I'm not saying it's a bad idea to necessarily encourage people to move on to an application to generate two-factor authentication codes, but it's a bad idea to remove two-factor authentication from a bunch of user accounts. Can we make two-factor authentication better, though? I've complained about its experience. It takes time. We have these 2 steps. Can we make it better? Well, yeah, it turns out, thankfully, we have some APIs for that as well. I'm going to go back to the HTML for a second. I see that autocomplete attribute is still wonderful. Comes back again. If you add autocomplete one-time code to an input element in Safari, desktop or mobile, and a text message is sent with a 6-digit code for it, then Safari will be happy to autocomplete that for you. It makes it a one-tap experience. It's really nice. Adding input mode of numeric is also good because these codes tend to be all numbers, and that pops up, at least on mobile, pops up a number keypad, making it easier just to fill it in. So this is what that looks like. I've got video for this. We're going to log in on an iPhone device. It's going to send a text message, and then the autocomplete attribute pops in, and we can see right there, top of the keyboard, single tap just to get the 6-digit code in. You tap that, it autofills. It actually auto-submits the form as well for you, which is even nicer, and you're in. Nice experience. You didn't have to open the SMS app. You stay focused on what you're doing. It's a second step, but it moves by quickly. It works on desktop as well, which I think is kind of incredible. So here we log in Safari on the desktop, and it's going to send the text message to the phone, and then it pops it up. Oh, well, that comes up so small. It pops it up in the autocomplete on the desktop, which I think is kind of a magical experience. Sure, you have to be a die-hard, dedicated Mac user, everything being Apple-based in order to do this and have your iMessage set up to come to your laptop, but it gives you that autofill right there, and that's nice. It's a good experience. So that's all the Apple stuff. Of course, Android and Google have gone a different way with this. Android, Google, Chrome, all that kind of stuff have gone a slightly different way with this, with what we call the WebOTP API. WebOTP is actually just the credential management API under a different name, which is nice. I told you this talk was going to be about the credential management API. But instead of password credentials in this case, we actually look for an OTP credential. Now, this works with SMS kind of OTP, so we're not currently talking about this for application-based stuff. But you have to change your SMS in order to get this to work. And instead of just the message, you need to add this bottom line to the SMS, which has an @ symbol, the domain you're logging into, a space, a hash, and then the code. That actually allows it to stop being used for phishing purposes. It will only offer, it's going to autofill the code in, but it's only going to offer that on the domain that the text message says. So if you're being phished, this will not help the phisher, which is nice. And like I said, we're not using password credential, we're using OTP credential this time. And we can't store this credential. It's not a thing we're trying to store. We just ask to get it. We're saying, hey, to the system, can we have this 6-digit code? And so you ask navigator credentials get, and you pass an object which contains a property saying OTP, and that is an object, and it has a property that says transport, and that has an array which has one item in it, and that's the string SMS. It's a confusing API, because nothing else can go in that array. But it's there. It's how it works. If you do that, the browser will pop a permissions dialog up to say, hey, can we use this number from your text message that just came in? And if the user says yes, you get access to an object which has a code property, and you can fill it into that form. And it looks a bit like this. I have to be ready to pause this because I always do this too quickly, even in recordings. So we log in, the text message comes in. We actually see, I'm going to pause it there. We actually see the text messages coming at the top. The permissions dialog is at the bottom. It's maybe a bit confusing, but that's up to the operating system to eventually sort out. But here we have at the bottom, do you want Chrome to be able to receive the message, read the message, and enter the code? And if the user clicks allow, which they're going to do so in this case, it fills it in automatically, and we move on. I think it's cool. Turns out two-factor authentication can be a good experience. We end up with 2 minimal steps. If we're using the credential management API to do both our passwords and our two-factor authentication stuff, we end up with this like 2-click process to get through a login system, and that's amazing. It doesn't stop the fact that you still need to receive a text or receive a code somehow. So you need that device, and you need that other app, and you need phone signal, of course, if it is coming over SMS. But it's such it speeds you through that process so much nicer when it works. And of course, this hasn't changed the security side of things. The two-factor authentication continues to sort of overcome poor or leaked passwords. It's less vulnerable to phishing, particularly with that web OTP requiring the domain name on the message. It's less vulnerable to that. It doesn't stop those targeted SMS attacks, though. It is a shame that this doesn't currently work for authenticator app kind of experiences. But if we think back to that API, which has an array with just the string SMS in it, the intention there, and this is the best part of the web, and people building the web, build things for extensibility. We have that array so that in the future, if browsers, operating systems, and authenticator apps can all work together, we could have authenticator app as a option for that array, and be able to request things through the operating system, and it will be amazing. I feel like it's sort of coming. Like iOS seems to have certainly upped the availability of looking through apps to get this kind of stuff. So we may be getting there, but right now this minimal step kind of thing is about is about text message-based stuff, which is still secure for most people. We can go more secure with two-factor authentication, though. I bet many of you in the audience right now have a security key, a YubiKey, or something like that you've plugged into your machine and is generating secrets for you. This is capable in the browser using web authentication, WebAuthn, which turns out is the credential management API again. It's all the same API, guys. It's navigator.credentials. It's there. So web authentication allows you to create a public-private key pairing, allowing you to sign a challenge from a server using your private key, which the server using your public key can agree with, verify. It knows that you are you because you have your private key and they have your public key. It's amazing. So this is how it works. On the browser, well, so the server needs to send a challenge, a random string of bytes, down to the browser. The browser can then ask Navigator Credentials create a public key using this challenge. We have this option of RP, which has an ID. It's a relaying party. It just means the domain that you're on. You put some user details in there, right there, and then we can also offer some algorithms that you can use to create this public key. And this is going to ask the user to interact with that security key that's plugged into their device. And when they do so, they create the public-private key. They keep the private key on the device at all times. It never leaves. And what it does is it uses the private key stays on the device, never leaves. We use the private key to sign this challenge and return both the public key. Do not return the private key. We return the public key and the challenge to the server. The server can then use the public key to decrypt the challenge and make sure it was the same as the original challenge, and at that point you can verify that that is that user. Once you've done that, the server now can store the public key, and when we come back to do another authentication, we use Navigator Credentials get instead of create, and this time the server will send another challenge, and so we do a public key one. we use another challenge from the server, and we have to sort of allow the available credentials, a public key credential. We can set where those things can come from, so a USB, Bluetooth, or NFC thing works. But yeah, again, now all we need to do is sign using the private key and return the signed signature. The server can then use the public key to verify that that is the same person again. And we're good, we're golden. Web authentication is brilliant. And this is good. This is a great experience because we have these two minimal steps. You just have to interact with that private key, interact with your key device, and it's done. It's a very swift experience. Sad thing is most users don't have one of these plugged into their machine. They're not all developers with AWS credentials or Azure credentials to look after. And so they probably don't have an authenticator key. That's a shame. And also, these things are tied to the key themselves. The private key is stored on the key, and so you either need to move it around devices or store multiple keys. But the security is obviously fantastic. That's why we are paid to use them. There's no problem. We have a second factor that can't be leaked. We're now on public and private key cryptography. If we only ever send the public key, and I felt like I said send the private key a bunch of times back then. I didn't mean ever. Only ever send the public key back to the server. Always keep the private key. And we don't get a control over that. That's what the API does. It will never let us have that private key. It only signs things for us. That public key can go to the server, and it actually doesn't matter if that public key is leaked everywhere, because all it can do is verify the signature from the private key. And thus, this is phishing resistant as well, because the API will only ever work on the domain on which you set it up, on that relaying party's domain that you set when you created the key in the first place. So, brilliant. It's just you have to have the key for it. And so this finally brings us to the idea of how can we get rid of passwords entirely. We've got all sorts of two-factor authentication options to try and bolster the security of our passwords, but ultimately bolstering that security is causing us other problems. So can we just get rid of them? Can we just drop passwords entirely? The answer is, yeah, probably. It's going to be good. I'm going to start with a little diversion through magic links. I don't like magic links. This is where you go to sign into an account, you put your email address in, and it sends you a link to log in with. I don't like that. It's friction. Sending somebody to their email account is 100% going to put them off the thing they were first going to do. Email itself is a nightmare system of hoops you have to jump through in order to manage to deliver something to somebody's inbox. It takes time, but also you might end up in spam anyway. But it does drop passwords, so I kind of like that. And it's pretty secure, sure. It's whatever. Actually, I have one. I don't like them. I have one account I have to log into. It requires a username and password, and then it emails me a link, and I hate it. So we should drop that. It's pretty secure. Let's not do it. Let's move on to passkeys. Passkeys are the future. Passkeys is what we're actually all about. Once we've created all these other things to make life better, passkeys are the final thing that we want to use. Passkeys are multi-device credentials that allow us to passwordlessly log into devices. They're amazing. It's web authentication. It's still the credential management API. It's web authentication, but it requires the platform authenticator. In the case of my laptop here, it would be the fingerprint. If on my phone, it's the Face ID kind of thing. It requires a platform authenticator that can actually identify a user via biometrics. Or a password can be used afterwards, your sort of device password. It verifies the user on the device, and this is the best part of it, right? It verifies that you are who you say you are on the device, and it never has to leave the device. So when you are using a fingerprint or a face scan or things like that, then if you were sending your fingerprints or your face scans to third-party servers, they're going to leak them. They leak passwords all the time. They're probably going to leak the biometrics as well. And it's a lot easier to change a password than it is to change your fingerprints. So the fact that they never have to leave the device is brilliant. And so we've verified the user on the device, and then we can authenticate the user with the server. So using that public-private key cryptography again, we are generating a public-private key pair. We are sharing that public key with the server, But this public key is also tied to our identity, not just the device itself. And so it's sort of two-factor authentication in one, which is kind of cool. We've got verification on the device and authentication when we sign a challenge. Then, and this is the best part for users, regular users, it syncs across devices. It syncs across, so if you have an Apple account, you're in iCloud Keychain, those passkeys are encrypted and synced across all your devices. Same for if you're using sort of Android or a Chromebook. And it can sync across those platform accounts. There's actually been progress in this recently in which third parties have managed to get involved in the process as well. And so 1Password, the sort of password manager, its plugin is now intercepting web authentication passkey processes like this and allowing you to use 1Password to generate these public-private keys and then sync across your 1Password account. It's really cool. But then in the case where you can't sync across your device, if you have an iPhone but you use Chrome on the desktop, for example, there is a cross-device method of sharing that passkey using QR codes and stuff, and we'll see a demo of it in just a second. So it works for users regardless. I want to show a little bit of the code because I think it's funny. This is JavaScript, not Java. In order to use passkeys, you have to check for a couple of properties that exist on the public key credential inside of the credential management API. We have to know whether the user verifying platform authenticator are available, which just says, do we have a fingerprint or Face ID scanner or something that will verify the user available? And also, is conditional mediation available? That means, does the browser have a way to suggest accounts that have signed up via this method to the user? And you'll see what that looks like. Then you have to check whether the function exists, and then you have to call that function and wait to find out if it does the thing you want it to do. And once you've done that, then we can do web authentication creation. We go back to the credential management API and use navigated credentials, create with a public key. It's mostly the same kind of stuff that we saw for web authentication and USB kind of keys. But the difference is that we asked for this part. We asked for authenticator selection to be a platform authenticator. Again, we're looking for the authenticator that's on the device. And then, I know people aren't massive fans of this, but it requires it to be a resident key. That means the key gets stored on the device. So some platform authenticators some authenticators, not necessarily the platform ones, don't have an awful lot of space. But right now, this requires it to be stored on that device. So that's going to get better. And indeed, actually, currently it's not possible to delete them from the device, but that's also going to change in the future. But these are the two things we have to say, hey, we need this in order for it to be considered a passkey. And so this is what it looks like. I'm using passkeys.io to show this. And what we're going to do is start by, I'm in Safari on my desktop, logging in. Now, I've done this demo a few times. I'm logging in this case, with my Sona email account, so we need to look at that. This is the registration. We're creating the passkey right there. It asks for the fingerprint, and it's done it, right? It's taken that challenge. It's got my fingerprint. It's signed the challenge, sent the public key back. And then we can go log in again. Like I said, I've done this a few times. So we have our sonasource.com email address at the bottom. I say yes, and then fingerprint it, and we're back in. This means this is giving it time to sync to the iPhone, which is also on screen. So I can open up the same website, use sign in with a passkey at the bottom, pick my Sona email address, do a Face ID on it this time, and we're signed into the same account. In merely seconds, it had synced across that and allowed us to log in. Now, if we pick a different browser, if we go to Chrome, I can say sign in with a passkey, but Chrome hasn't synced the passkeys from Safari, but it gives us this QR code, which I can then open on my phone, on my device, scan that with my iPhone in this case. It'll say sign in with a passkey. Again, I can now choose the account I want at the bottom, Face ID, and it will log me in on the Chrome application. which I think is very cool. And so whilst Chrome was unable to sync from Safari, it was capable of syncing, or was capable of doing this kind of QR code method. And whilst this is just a demo application, what you would then do if you're building this for real life is offer the user to register this device as a passkey as well. And so they can register multiple passkeys so that the next time they can just log in using the password on their own device. This does sort of predicate that we expect users to have this mobile device, which allows us to go do this kind of cross-browser syncing. But again, in this kind of stuff, I'm looking for the best thing for most users. And it turns out, yeah, having a mobile device is what most users have, and they mostly have a camera on it, scan QR codes, and all that kind of stuff. And so passkeys are absolutely brilliant in my mind. If we were to toss up the difference between passkeys on experience and security, it turns out it's a great experience. We now don't need a password for this. We are verifying the user and authenticating the user in one step on our device, on their device. Its drawback is it requires this platform authenticator. Like I said, most users these days have devices on which they have a platform authenticator, they have a fingerprint, they have a face scanner, things like that. And then the fact that it syncs across devices is brilliant. It means the user doesn't have to set up anything in order to make this work. If they are just logged into a platform account, which, again, most users are, then it will work for them. I sort of laugh at that because this is my work laptop. I'm not allowed to log into it, which is why that's a video demo rather than a real one. My passkeys don't sync between my things right now. At least I understand why, though. On the security side of things, it turns out it's phishing resistant. There's no passwords. There's no leaking. It's public and private key cryptography. You can share that public key anywhere, but it will only work on that one device, on the one website on which you signed up and the one domain on which you signed it up on. And I'm not a security professional. I just really like this stuff, but maybe it's perfect. Maybe. I know there are arguments against that. The fact that you kind of need some kind of syncing platform account. Some people don't trust Google or Apple in order to look after their things like this. Although I think actually that's got better because as I've seen 1Password kind of provide a plugin to add them as a syncing account, then you can choose your own. And in fact, I'm sure at some point there'll become available a self-hosting passkey platform which you can look after yourself. That sounds less secure to me. I'd rather Google looked after it than me, but each person has their own desires on this. So yeah, I think it's absolutely amazing. I think this is the future, and we need to build it now. And so there are a couple of other drawbacks. Browser support is one of them. My favorite browser, Firefox, my favorite browser I use right now, Firefox, Internet Explorer has been removed. Firefox doesn't currently support this, but it's supposedly coming. I've seen the phrase coming in 2023 for Firefox for a long time, and we're running out of 2023. But come on, Mozilla, you can do it. But other major browsers now support this. Firefox is the only one sort of lagging behind. It is coming. If you're interested as to where you can go and use passkeys, where you can remove your passwords, 1Password has been maintaining this passwords.directory website, passkeys.directory, not passwords, passkeys.directory, which gives a list of places that you can use passkeys either as a second factor or as a primary factor. It doesn't show it on here, but just a couple of weeks ago, Google has actually, for Google accounts, you can now register a passkey as a primary way to log in to your Google account. It's the case for GitHub and indeed Microsoft accounts as well. You can do that. eBay, Amazon, sometimes only in certain geographies as they test it out. But many major websites are actually doing this. And I think that's only better proof that we should now be implementing this, doing this. So I have final recommendations for this. What we should be doing, how are we going to protect our users for the future? First up, I think we should be building in passkeys now, detecting for it, and offering it as the primary way to register, or indeed when you are doing password resets or anything like that, offer up a passkey before we offer up password as an option. It's more secure and a better experience. We do need to support multiple passkeys. This syncing experience is great. Syncing experience is great if you're all on the same platform, but you do need to be able to register multiple. We still need to be able to fall back. I know there's not that many Firefox users in the world, but we do still need to fall back in the case where it's not possible. And so fallback's password, but include two-factor authentication because we still need to keep people safe. And then finally, once a user can use their passkeys, you can offer them that opportunity to upgrade and indeed remove their old weak credentials. I really like this idea that you can detect this even as a user's logging in with their password and say, hey, do you want to change that to a passkey? And then also offer, do you want to just remove the passkey as well? And just upgrade their experience entirely. So those are my recommendations. I think the state of passwordless auth on the web right now is that we can and should build it. We need to build with passkeys so that we can make people safer and happier and give a better experience. I have a bunch of links that are really useful. I will share these slides in the NDC Slack, including all of these links, which give you all the information on sort of all the methods that you can use to make existing things better. And like, if you take nothing away, if you don't like the passkey side of things, at least take away some of the ways to make the user experience of passwords better and the security of passwords better. But I absolutely want to see passkeys implemented as well. So that's all I've got for you. Again, my name's Nash. I'm a developer advocate at Sonar. And I'd love to have a chat with you during the break or whenever for the rest of the day. I'll be around. I'm in a purple shirt. It's relatively easy to spot. But thank you for joining me, and let's get rid of passwords.